welcome back to my channel. This is Pragya Jain, and in this video we are covering a topic of neural network. So the neural networks are the computational models that mimic the complex functions of a human brain. The neural network consists of interconnected nodes or neurons that process and learn from the data, enabling tasks such as pattern recognition and decision making in machine learning process. The neural network are powerful machine learning models that can learn the complex tasks by analyzing patterns in the data. So now we have to set up the Python environment. First we install the Python, then we set up a virtual environment, then install the required libraries. Now, understanding the fundamentals of neural networks, we have neurons and layers, weights and bias, and activation functions. Neural networks are composed of interconnected nodes or neurons complexed into the input, hidden, or output layers. Weights and base are the each conditions between neurons such as associated weight, and each neuron has a base value and influence its activation. The activation functions determines how the weighted sum of the neurons inputs into transformed into the output. Now we are implementing the simple neural network from the scratch. You have to define the network, then implement the forward propagation, then implement the backward propagate errors. First, you have to define the network, specify the number of input, hidden, output layers, output neurons, initialize the weight and bias. Then you have to calculate the output of each layer by applying the activating functions by weighting some of the inputs. Then you have to compute the gradients of loss of function with respect to the weight and bias and update them. So this is the basic method for implementing a simple neural network from scratch. Now you have to explore the activation functions and their roles. We have sigmoid, REUL, softmax, and many more. So this maps input into a value between 0 and 1, useful for binary classifications. ReLU applies for the rectified linear unit functions which sets negative inputs to 0. The tan similar to sigmoid but maps input value between -1 and 1. The softmax normalize the output of the last layer to represents the probability of distributions. Now we have to train the neural network. We have using a method of backpropagation algorithm here. You have to pass the forward pass, then compute the errors, backward propagation errors, then update the palms. Compute the output of each layer given in the input to current weights. Calculate the difference between the predicted and the targeted values. Propagate the errors. Use gradient descents to update the weights and bias to minimize the loss. Now the regularization techniques for preventing overfitting. So you have L1 regularization, L2 regularization, dropout, and early stoppings. The L1 regularization encourages sparse weights by adding the absolute value to the weights of loss function. The adds and the squared magnitude of the weights to the loss function, penalizing large weights, randomly deactivates a portion of the neurons during training to prevent co-adaptions. Stop training when the validation loss stops improvising, avoiding overfitting. Now we have CNN for image classifications. You have a convolutional layers, polling layers, fully connected layers. Apply a set of learnable filters to the input image to extract a low key features. Reduce the spectral dimension of the feature maps, preventing imported informations. Map the high level features to the final classification output. Now we are using the Python for neural networks. You can use any other language as you want. In this video we are using Python. So first you have to import the necessary library of Python for easy running of code. We are here imported the NumPy as NP, load iris or train test split, sequential, dense or categorical, classification report, and many more libraries here. You can import according to your need. Then you have to load the data sets. We are adding features and labels, like x equals to iris.data, this is a feature, and y equals to iris.target is a label. Then one hot encode the targeted label, then split the data into training and testing sets, and initialize the variables like xtrain, xtest into the test size of 0. 0.3 and random state of 42. Now build a neural network. This is the main part of a code. Here you are building a network. You are creating an input layer, a hidden layer with 8 neurons, and an output layer. Now you can compile the model using a model.compile method. Then you have to train the model by using a model.fit method, and print. Then you have to print the evaluation model, or you can say you get the evaluate model on the test set. Then you have to make the predictions using a predict model.predict np.argumax and np.argmax. Now you have to print the classification report that we have conclude, and here is one of the examples you can refer for further future reference. Now we have RNN for sequencing modeling. Here we have a sequence input, a hidden state, and output predictions. The sequence input process of data such as text, time series, and so on. We have then a hidden state. The hidden state of RNN captures information from the previous time steps. Then we have an output prediction. Each time step is generated based on the current input and hidden steps. Now we have a practical consideration and the best practices that are hyperparameter turning, data preprocessing, and monitoring and evaluations. Carefully selecting a learning rate, bench size, and other hyperparameters is crucial for optimal performance. You have to pre-process your data for scaling and normalizing, and handling missing values in input data, and regulating the evaluate the model performance on a held out set on the monitor for overfitting and underfitting. That is it for the video. Thank you. I hope you understand.